Okay. So Charan Lal has told me to take up the divisibility. Everyone can see the screen, no? No problem.
Yes, I can see.
Okay. So normally the divisibility by Vedic mathematics is observed mainly for the prime numbers. So everyone knows what is prime number.
Yes.
Yeah. And initial the conventional method by conventional method.
Yes, yes, we know.
So I can go fast because I think everyone knows what is the conventional method.
Yes,
So
sir.
I did not spend much time on this. But anyhow, what is the divisibility of 2? So when divisibility is required, when divisibility of 2, that means it is a divisor. By some number given, means 2, 3, 4, etc., it is known as dividend. So we will be seeing the divisibility of the divisor. So whether a number, say 2, 3, 4, is divisible by 2, that means it is by divisor 2, what is the divisible, whether this number is divisible by 2. So what is the divisibility of 2? Yes, you can reply me. Anyone can reply. Yes. Are you able to hear me?
वैदिक मैथ्स वैदिक मैथ पढ़ने लगे साधु के का भी तो तुझे नींद आ रही है ऊपर से चलती रहे ये लोग जूम मीटिंग ले रहे मैंने तो बता देना वैदिक मैथ्स टीचर का
Are you able to hear me?
Yes, sir.
What is the divisibility of 2?
234.
Whether this number is divisible
Divisible
by
by 2.
Yes or no?
Yes,
Why?
because we have even number as unit place.
Yes,
And
at unit place should end with 0, 2,
or even number.
4, 6, or 8.
Yes.
What about divisibility of 3? So here you know what is Bijank.
Yes.
Bijank, you know what is Bijank?
Sorry.
Do you know Bijank?
Sorry, sir.
Digital root, you know?
Yeah, digital root I know.
So digital root itself in Sanskrit it is known as Bijank.
Bijank. Okay.
Bija means seed.
Okay. Sum of all the digits means Bijank means sum of all the digits.
All the digits to
Okay.
a single digit.
Okay.
Anka means digit. So if the Bijank or if the digital root is divisible by 3, then it is divisible by 3.
3, yes.
So 2, 3, 4, whether this number is divisible by 3. So 4 plus 3, 7, 7 plus 2, 9. 9 is divisible by 3. Therefore,
yes.
234 is also divisible by 3. What
Yes.
about 4?
4, no.
What is the divisibility test? Later on, we will see.
For last 2 digits should be divisible by 4.
Yes. Last 2 digits divisible by 4. What about 5?
There should be 0 or 5 in the unit digit.
0 or 5 ending.
ಸೆಕೆಂಡ್ ಪೇಜ್ ಇಂದ ನಂಬರ್ಸ್ ಬಂದವು ಬಂದಾಗ
Or
ಅದನ್ನ
5
ಜಸ್ಟಿಫಿಕೇಶನ್ ಆಗ ಅದು ಆಗುತ್ತಲ್ಲ
6.
ಗ್ಯಾಪ್ಸ್ ಹೆಚ್ಚಾಗೋದು ಕಡಿಮೆ ಆಗೋದು
6 is same as 3.
No.
Uh,
What are
it
the
should be
factors
divisible by 3. No. It should be divisible by 3 and 2 also.
Yeah, because the factors of 6 are 3
Or 2
into
3s.
2.
Yes.
So it should satisfy the condition of 3, which
3
is
and 2.
this, and
Yes.
satisfy the condition of 2, which is
2.
this.
Yes.
What about 7?
7.
There is no conventional method at present. So we'll deal with Vedic method. What about 8?
Sorry, sir. For 7.
For 7, we'll study Vedic method.
So later we'll study.
Later we'll study.
Okay.
Last for 8.
8
Last
factors of
3
8
digits.
are should be divisible by 4 or 8.
No, last 3 digit divisible by 8.
8.
Like
So
for 4 last
sorry.
2 digits.
No, sorry, sir.
For-
As we see in 6, the factors are 2 and 3. So
Yes.
for 6, it should satisfy the both the divisibility rules for 6 and
Yes,
3
yes,
and
yes, yeah.
Same. Can we do it for 8 also? Because
Yes,
for 8,
you
the
can.
factors are 2 and 4.
Yes. So you have to take it for 2
and 4. Yeah.
4 and
Yes.
2, correct?
Yes.
Suppose
So
if
both
it is if it
if a
is
number
say
set is
124, whether it is
Yeah.
divisible, first you will see of 4, correct?
4. Yes.
And then you will see of 2. So
2.
2 times you will be doing. Instead of
Yes.
that, last 3 digits
Okay. Should be divisible by 8.
should be divisible by 8. So it is like say 2, 3, 4, 5, 1, 2, 4. Whether it is divisible by 8,
Yeah.
you take only last 3
Need
digits.
last 2 digits. Okay.
Last 3 digits for 8.
Mhm.
Last 2 digits for 4. And last digit for 2.
Okay.
So it is 2, 2 to the 4, 2 3 the 2 4 the 8. Like. So last digit even, that is test for 2. Last 2 digits divisible by 4, that is test for 4. Last 3 digits divisible by 8. So here it is how much? Last 3 digit.
3 digits.
So 8 ones are 8. If you consider only 124 out of this whole number, 8 ones are 8, carry over 4. It is 8 6 are 48 or 8 5 are 40. So it is not divisible. So by 8 it is not divisible.
Okay.
Correct? So
Yes.
here what you have to do? First divide by 4.
Last. Okay.
Okay. Now if you divide by 4, how much it is?
32.
124 divided by 4 is how much?
31.
31. And what about 2? Because it is odd number, it is not divisible. Like that 2 times you have to do it.
Yes.
Whereas here directly, if you consider last 3 digit, whether it is divisible. If it is 128, if it is 128, whether it is divisible by 8, means 8 ones are 8, carry over
6.
4, 8 6 are 41. Therefore, yes, this number is divisible. And if you do other way also, by 4 also, 4 3s are 12, 4 2s are 8. Again, this is 2 means divisible by 2, divisible by 4. Yes, it is divisible by 8.
Yes.
But it is better to have 3 digits
Last 3 digits. Yes.
by 8. That is best. Clear?
Yes.
So, especially for 2, 4, 2 to the 4, 4 to the 8, 8 to the 16, if you consider, Here only last digit, even. Here last 2 digits.
2 digits.
Here last 3 digits.
3 digits.
Here
Last 4 digits.
4 digits. So 2, 8, 2, 4, 8, and 16. This way you can do it. Okay.
Yes.
Now come to 9. What about 9? The digital root must be 0. That's all. Digital sum or bijank must be 0. 9 means 0 itself because we cancel the 9 to see the bijank, correct?
Okay.
What is the bijank of 7, 2, 3, 9, 4? What is the bijank?
7.
Because 9 cancels, here 7 into 9 cancels. We cancel it. That means we think that it is 0. Its value is 0. That's why we
ಒಂದು
cancel.
ಕಾಗ್ನಿಸೆಂಟ್ ಐತೆ ನಮ್ಮ ಮಕ್ಕಳನ್ನ ಇಂಟರ್ವ್ಯೂ ಕಳ್ಸ್ಕೊಂಡ್ರು.
So 4 and 3 sevens is the bijank. So if the bijank is
ಮೊನ್ನೆ
0,
ಬಂದಿತ್ತು ಡೇಟ್ ಶೆಡ್ಯೂಲ್
so
ಆಗಿತ್ತು.
whether this number,
ನೇಮ್ ಅಪ್ಡೇಟ್ಸ್ ಆಗ್ತವೆ. ಇಂಟರ್ವ್ಯೂ ಚಿನ್ನ ಕೊಟ್ಟಿದ್ದೆ.
whether this number is divisible by 9, tell me.
ಓ ಹೌದಾ?
9 you can say. Just a second.
ನಂದು ಯಾವಾಗ ಆಗ್ಬೇಕು? ನಂದೊಂದೇ ಬಂದಿರೋದು ಅವರಿಗೆ ಹೆಚ್ಚಾಗಿ ಎಲ್ಲ
Yes, sir. It is divisible by 9.
Earphones, stitch.
1 remaining.
No. No, this is not divisible by 9. No, sir. We cannot hear you. Wow.
Why?
Hello.
Yes, sir.
Now you can hear me.
Yeah.
So now you can hear me.
Yes, sir.
So what is the divisibility test? 9 means the digital root should be 0.
0.
So if whether this number is divisible by 9. So what you do? You cancel first all nines.
Yes.
7 and 2, 9. Like that, here it is 4 and 5, 9. 6 and 3, 9. 7 and 2, 9. 1 and 8, 9. And this 9, this 0. So what is left is 1. 1 is the digital root. And if this is not divisible by 9, that means the whole number is not divisible by 9. Is it clear?
Yes.
So whether this number is divisible, you can tell me 3, 4, 5, 7. Whether this number is divisible by 9.
No.
Because 4 and 5, 9, 7, 3, 10 means 1. 1 is
One.
not divisible. Or even if you take 10, 9 ones are 9. 1 is left.
No.
So whatever bijank is there or whatever digital root is there, that itself is the remainder in case of 9.
Oh.
Okay. So you
Okay.
take, say, if it is 32, is it divisible by 9?
No.
What is the digital root?
5.
The 5 itself is the remainder.
Remainder. Oh.
Check. 9 threes are 27. Remainder is 5. Is it clear?
Yes.
So for 9, especially for 9, whatever digital root is there, that itself is the remainder. Clear?
Yes, sir.
So what about 10 divisibility test? It should end with 0.
0.
What about 11? Do you know the test for 11?
11.
Sum of odd places and sum of even places.
Right. Difference between sum of odd and even place numbers. If it is 0 or multiple of 11, it is divisible. Otherwise, no. Clear? So if it is say 2, 3, 4, 4, 3, 2, whether it is divisible by 11 or not. So you alternate, you take 2 plus 4 plus 3. So 2 plus 4, 6 and 3, 9, and other alternative 3 plus 4 plus 2, which is 9, and the difference is 0. Therefore, this number is divisible by 11. Clear?
Yes.
So whether this number is divisible, just tell me. 2371. Now alternate addition is how much? This is 4, this is 9. 9 minus 4
As
is how
4
much?
is 5.
5. So 5 is not
Is not
divisible.
divisible by 11.
Therefore, the whole number is
Number
not
is
divisible.
not divisible.
ಹೊರಗೆ ಈ ತರ ಎಲ್ಲ ಯಾವ ಆಗಂಗಿಲ್ಲ ಅಂತ ಹೇಳ್ಬೋದು.
So, whether 9,
So can you explain the division with 11, that example 2, 3, 4, 4, 3, 2 again?
okay. You have to take odd numbers and even numbers. Addition of odd place, unit place. Leave tens place 100. Leave next place, next place, like that. So after 2, alternate means what? Leave this, add this. This plus this. Leave this, add this. So total is how much? 2 plus 4 plus 3 is how much?
9.
9. Now what is remaining? 3 plus 4 plus 2 is how much?
Again 9, sir.
So what is the difference between this and this?
0, sir.
0. Therefore it is divisible. If it is 0 or multiple of 11. Okay, here whether this number is divisible by 11, what is the addition of this first, this
4.
and this?
13, that is 4.
14. And here it is how much?
9.
14 minus 9 is how much?
5.
5. So whether 5 is divisible by 11,
No, sir.
therefore whole number is not divisible. Whole number is not divisible. Okay.
Yes, sir. Thank you.
Okay. So we'll take one more example if you want. Just 1, 0, 4, 15. Whether this number is divisible by 11. So what is the alternate sum? Here it is how much?
4,
15 minus 4.
And here it is how much?
15.
What is the difference
11.
between 11?
11 is divisible.
So yes, it is. This number is divisible by
11.
that's all. You confirm it. You confirm it by 11. 11 ones are 11. What is left is 6. 63. 11 fives are 55 and 8. 11 eights are 88.
88.
So it will be. So you need not do all these things. Just observe alternate addition.
Odd
The
places.
So unit place, hundreds place, 10,000 place, and so on. Then tens place, 1,000 place, here 1 lakh place, and so on. So like this it comes. Like this it comes. Clear? Any doubt?
No, sir.
So what about divisibility test of 12?
6 and
Again,
2.
like this, it is 4 into 3. Because if you do it 6 and 2, again 6 means again 3 into 2.
Yes, sir.
Therefore, it is
Direct
better
is 4 into 3 only correct.
directly you can do this. Because, say, suppose if it is 6, 2, 4. Now, last 4, what is the test for 4?
Last two digits.
Whether it is divisible?
Yes, sir.
Yes. Now, what is the test for 3?
Sum of all numbers.
Yes. What is the sum of all these things?
12.
12 means 3.
3.
Bijang, digital
Yes.
root.
Yes, sir.
So 3 is divisible by 3. So
Yes, sir.
whole number is divisible by 3.
Divisible by
Check. 12 5s are 60. Remainder 2. 12 2s are 20. Clear?
Yes.
So instead of doing all those things, it is better to have last 2 digit for 4 and 3 digital root must be divisible by. That's all. That is the test for 12. Clear?
Yes.
So for 13, there is no test. No conventional test. For 14, what are the factors?
so
2 and 7.
2 and 7, but
For
we don't know.
7, there is no test. 2 you can have, but not for 7. So gone. 15,
5 3s.
the last ending should be 0 and 5. Digital root must be divisible. That is the test for 2. 16, last 4 digits.
Last 4 digits.
17, no test. 18, 2 into 9. So Bijang or digital root should be 0 and ending with unit place to test for. So both should be satisfied. 19, there is no test. So like that, conventionally afterwards it is very difficult to, but Vedic mathematics provides these tests. So this is clear, or any, if at all you have any difficulty, you can ask me. Is it clear now?
Yes, sir.
Hmm?
Yes, sir.
So these are the conventional tests, not Vedic tests. These are conventional. Routinely you are following, or we were also following when we were youngsters. We were following these tests, but later on there are no tests actually, and especially the prime numbers. You have seen now, there was no test for 7, no test for 13, no test for 17. All these are prime numbers. Again, if you at all you consider 21, though it is not prime, it is factors are prime, 7 3s are 21. So there is no test for such numbers, all prime numbers. And what are the prime numbers? What is prime number?
It is divisible by itself.
Itself or into 1. 1
Yeah.
into that. These are the factors. There are no other factors. If at all it is composite like this, 7 and 3, both are again primes.
Yes.
So odd primes, so to say, odd primes are the one especially which end with 1, 3, 7, and 9. So 9, you can see 9, ending with 1, ending with 7, ending with 3.
3.
So 1, 3, 7, 9. Especially such numbers, they normally we don't have any test, but Vedic mathematics provides the test, and that's what we are going to do now. Okay.
Yes.
So 9, ending with 9, what are some numbers?
1.
29, 39, 49, 59, ending with 9. What are ending with 21? 31, 41, 51,
51,
61.
61.
So ending with 1 means unit place is 1, unit place is
There should
9,
be
unit place is 7. 7 means
27, 37, 47,
and 7. 13 means
23, 33,
33, 73,
43.
93, whatever it is.
Yeah.
Ending with 3, ending with 7, ending with 9, ending with 1. So they will end with, clear? So the test, divisibility test, learning for this. Okay. So very easiest is ending with 9. Numbers ending with 9. So you know some Vedic formulae, ekadikena purvena, ekanyonena purvena. Do you know this formula?
Sir. Yes, sir.
So what is ekadikena purvena means what?
9 plus 1 is 10.
Not for 9. General I am telling. Generally I am telling. Any number.
Any
with
number, addition of
add
1.
Addition
Yeah,
of 1.
yeah, 1.
One more of 32 is
1 more, 33.
33, like that. So when in this case we use the formula ekadikena purvena, that means one more than the previous one. So if you want to see the divisibility of 19, you use the formula one more. One more is how much?
Plus 1.
20.
You cancel the 0. What is left?
2.
So instead of dividing by 19, you work with
2.
which is easier? working with 2 is easier or dividing by 19?
Sorry for the interruption, but there is lot of background now noise which is disturbing, and
Yes.
like I'm not able to hear what is going on.
So the one who has the children talking behind, just you can mute. Okay, is it clear? So now we are seeing the divisibility of numbers which end with 9, means 19, 29, 39, 49, 59, 69, whatever, ending with 9. Okay. So if we want to see the divisibility test of 19, what is to be done, that we'll see it. Now 19 plus 1 is how much? Because we are using the formula ekadikena purana, 1 more than it is 20. You cancel the 0 or 20, remaining is 2. So we work with 2 instead of dividing by 19. And this 2 is known as osculator. So osculator for 19, it is how much? 19 plus 1, 20, cancel the 0, 2 is the osculator. For 29, what is the osculator? Means add 1, you get 30, cancel the 0, you get 3. What is the osculator for 79?
8.
Directly, yeah, now you know that when it is 9, add 1 and write cancelling the 0. What about 129? What is the osculator?
13.
That's all. This is clear? Osculator, what is osculator? Then we can see other. So when we add 1 and cancel the 0, it is known as osculator. Because we are adding 1 to get 0 at the end, it is known as positive oscillator. Is it clear?
Yes, sir.
And positive means P. So P, when I write P itself means it is positive oscillator. Clear?
Yes.
So what is the positive oscillator for 59?
6.
6. Directly you have to tell 6. Or instead of, I will tell now what is the P for 69.
7.
So P means positive oscillator. Now what is the procedure? How we can find the whether the number ending with 9, whatever number is given, 19, 29, 79 and so on, whether it is divisible by that number. Instead of dividing by 19 or 29, it takes much time, correct? Whereas we can easily see, so if we suppose if we take 9348, whether this number is divisible by 19. So normally how much time you will take? You have to divide by 19 and you will see whether it is divisible or not. But now you see, so the process, instead of 19, the P is how much for 19?
2.
So we are working with 2. So that working is known as osculation process. Osculator means the number, and by which we osculate this number is known as osculation or process called as osculation. And this process is nothing but unit place into P, add this product to remaining number. Okay, what is the process? Just tell ma'am, Pooja ma'am. Osculation process is what?
Unit place into P.
Add this product.
Add this product with remaining number.
Okay. Now we want to see this. What is the unit place of this?
8.
8. Means remaining number is how much? Here, remaining number is how much?
934.
So I will write it 934 plus how much? Unit place into P. P is how much? 2.
2.
16.
2 is the 16. It is how much? Add it together.
950.
950. What is the now you here also here directly you can see because you know 19 5 are 95. Yes, it is. But even then 0 into 2 unit place of this number is 0. Into 2 is 0. Add to this means 95. Now I don't know the multiplication table of 19. I don't know 19 5 are 95. Again continue. What is the unit place of 95? Unit
5 into 10.
10 plus
10 plus 9. 19.
So finally we got 19. That means it is divisible. If we don't get 19 or divisible, then it is not divisible. If we get 18, 17, 16, 5, 4, 3, whatever it is, that is not divisible. So final figure must be divisible by that particular number.
Okay.
So now this much time you should not waste. Just write in this manner because it should be oral. 9, 3, 4, 8. Just to cancel 8 to the 16. Add orally 34 plus 16 is 50. So 9, 5, 0. Now cancel this. 0 into 2 is 0. Add to 95. So remaining is 95. Now cancel this. 5 to the 10. 10 plus 9 is 90. So it is yes, divisible.
So we have to repeat this process until we get the same number like divisor or less than this.
Yes.
Okay.
But it is much easier, no? Than
Yes.
dividing by 19.
Yes. Sure.
And do you know the formula Nikilam Navatash Charamam Dashataha? You have learned this formula. Last from 10, others from
All
9.
from 9, last from 10. Yes.
Right.
Yes.
You have learned. So
Yes.
now whatever I have cancelled what? I have cancelled 8, 0, 5 and last you get 9, correct?
Yes.
So just I will do like this. So here and here. For this number means 9,508. Okay, 9508. For this you apply the formula last from 10, others from 9. Here it is last from 10 is how much
10.
here?
2.
Next.
9.
Next.
4.
And next.
0.
So this gives quotient. So 9348 divided by 19 is equal to 492. Even you get the answer if it is divisible. If you someone has calculated, just you can refer, check whether this answer is right or wrong. Anybody checking? Hello?
Correct.
So how it is? How is this? So what is the osculation process? Unit place into P, product to be added to the remaining number. That's all. Clear?
Yes, sir.
So we'll take some 2-3 examples so that it will be clear. 69688, 69688, whether this number is divisible by 29. So in case of 29, what is P is how much?
3.
3.
So you have to multiply unit place by 3 always. Clear?
Yes.
Which is the unit place now? 8.
8.
I will just underline so that what is remaining number is this.
6, 9, 6,
8
8.
3 is 24. You have to add 24. 68, 78, 88 and 492. 69. Is it clear?
6,
Correct?
9 and 2.
Yeah.
Yes, sir.
Now this is unit place. 2 3 is 6. Add 6, 705. 2 3 is 6. 699 plus 6. 705.
5. 6.
Now unit place is 5. 5 3 is
5 2 is 10.
15.
5
3. Now
15.
it is 3.
3.
15.
Yes.
15.
85.
Now 5 3 is
15.
15 plus 8.
23.
23.
So whether 23 is divisible by 29.
No.
So this number is not divisible. That's if it is divisible, you can get the quotient. If it is not divisible, you don't get the quotient. Yeah. So this number 23 is not divisible
By 29.
by 29. Therefore, whole number is not divisible.
Not divisible.
That is the answer. Clear?
Yes, sir.
Now we'll take 209456. 209456. Whether this number is divisible by 19. So here T is how much?
2.
2.
2.
So 6 to the
6 to the 12.
12.
12. Add here 45 and 12.
57. 20957.
That's all. Now next 7 to the
14.
14.
14. 95 and 14.
21009.
9 to the
18.
228.
8 to the
16.
16.
16.
38.
38. Yeah, 19 to the 38.
Even otherwise, you go up to down if you want. Here you can stop. If you don't want,
Directly can.
if you don't want quotient, you can stop anywhere. Here also you can. 19 ones are 19, 3 is 12, 19 to the 38. Here also you can stop. But if it is divisible and want the quotient, proceed. That's all. Till you get the divisor. Now 8 to the 16 and 3, 19. So yes, it is divisible. Here, are any difficulty here?
Sir, if some number is not divisible, is it not possible to find out the remainder
By
and
this,
question book?
by
Yes,
this
sir.
method,
By this method, yes, sir.
by this method, it is not possible. By a reverse osculation, one more next time we will be learning. There it is possible. There you will get quotient also and remainder also.
Okay, thank you, sir.
But here, if it is divisible, then only you will get the quotient.
Yes, sir.
Now apply. 9 and means 0. 8 means
1.
this 8 means another one.
1.
This 9 means
9. 0.
this.
2 and 3.
2.
And last from 10.
4. 4.
4.
4.
4.
This is the quotient. Is it clear? Otherwise, how much time you would have taken? Just I'm writing it slowly and clearly. That's why it is taking time. Otherwise, once it is practiced, if you have the practice of adding, it is much faster, very easy and fast. One more you can take. 16617 whether this number is divisible by 79. What is P is equal to how
8.
much?
8,
Now continue with the similar question. 7 8 the
56,
so just you can write otherwise 56 is 7 1
7,
7
1.
1 7 8 the 56 again. Again 7 8 the
78. No.
No.
if it is 79 only then only otherwise
Yes.
like this you have to carry out. So 9. Now suppose, so is there any difficulty in this? Now I will take, just
No,
I will
sir.
tell you. Whether this number is divisible by 29.
3 is the P.
327.
So P is equal to
3,
3.
24,
24 and 5.
28,
29.
87029 27.
9 3 is 27.
9.
9, 9, 8.
9 3 is 27.
7.
6 3 is 18 and 11.
29.
So
Yes.
Yes, sir.
yes, you can write either yes or divisible, whatever. Apply the formula. This is 0, 6 and 3, 9 and 0, 9 and 0, 8 and 2. Last from 10. That is important. So 3002 is the question.
Quotient.
Is there any difficulty?
No, sir.
Hmm? Okay, like that now you can easily find the divisibility of 19, 29, 39, 49, 59, 69, etc. Till you get the what you call multiplication table, so to say. Because if it is 129, so P is how much divided by 112? P is equal to 13.
13.
If you know the multiplication table of 13, like this you can do it.
Yes, sir.
Like this. Correct?
Yes, sir.
So how much ending with 9 you can go? It depends on you what number, that what osculator you can divide. You know the multiplication of 15. So you can as well divide by 149 because P is equal to 15. You can do that. If you want to give anyone having calculator, they can give any, say, 109, 129, 139, any number into something, some 3-4 digit number and give me the number. Let us solve it. Do you have any calculator with you? Anyone? Just ending with 9, any number you can give. And you also know, because you are using calculator, you know the quotient also. So you write down in your notebook what that 3-4 digit number is there and tell me the number so that others can solve. Everyone. Are you giving someone?
712,206.
712,206
Divided by 109.
Whether this number is divisible by 109, that is the question. So here P is equal to how much?
11.
11. So 11 6 are 66.
66.
6 8 7 1 2.
71286.
6 11 are again 66.
7194.
44 54 63.
3 to 7.
763.
33.
109.
So yes, it is divisible. Now 9 means 0, 3 means 6, 4 means 5, 6 means 3, 6 means 4. This was the question.
Yes.
Otherwise, how much difficult it would have been by normal division?
6,
So
3, 4.
any difficulty?
No, sir.
Wow.
So now there is no difficulty in positive oscillator, correct?
No,
Yes.
sir.
Now we'll, so there is no difficulty no here?
No difficulties.
No, sir.
Okay. And now we can start with number ending with 1. Divisibility of numbers ending with 1. So what are some numbers ending with 1? 21, 31, 41, 51, 81, 91, 121, and so on, which end with 1.
Okay.
So here, the oscillator, there what you were doing for finding out oscillator, you were adding 1, one more than the previous one. Here it is negative oscillator, means one less than the previous one. What is 21 minus 1? 1 less than the previous one. What is 21 minus 1?
20.
So cancel the 0. So the negative oscillator is 2. Positive oscillator is 2 for 19. For 19, number ending with 9, add 1. Number ending with 1, subtract 1. So this is negative oscillator and it is denoted as Q, small q. And this is small p. So for 19, positive oscillator is 2. For 21, negative oscillator is 2. So instead of 21, here also we are working with 2 only. Here also we are working with 2 only. But this is positive oscillator and this is negative oscillator. That is the difference. Is it clear?
Yes, sir.
So suppose if we want to take something divided by 21, 31, etc. 93062. 93062 divided by 30. I will directly say Q. Okay. Earlier I was telling P. Now I will tell as Q. So what is Q for 31?
3.
So you have to do the same thing. Unit place into oscillator, but because it is negative, you have to subtract that. That's all. That is the only change. For P, you will add. For Q, you will subtract the product. So
9300.
is 6 and this is 9306. 2 3 is 6 is subtracted. Just I will try to understand that. That's all. It is 9300. Again 0 into 3 is 0. So you will get 930. Again 0 into this is 93. Again 3 3s are 9. Here 9 minus 9 is
0.
So if it end product is 0 or 31 itself or divisor itself, it is divisible. And if it is 0, then only, like if it is 9 at the end, you can find by last from 10. Here, directly whatever number is there, that itself. So here it is 0, here it is 3, then here 2 zeros, and this is 2. This is the quotient. So for negative oscillator, you should get 0 at the end, then it is divisible, whole number is divisible, and the quotient is directly whatever is number, this, 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 this. Any doubt? Is it clear?
Yes, sir.
So we'll take one example, 460881. Whether this number is divisible by 41. So what you will be finding, P or Q?
Q.
Q. So Q is how much?
4.
So you multiply and subtract, multiply and subtract. 4 ones are 4, minus 4.
46084.
4 fours are 16.
5,
2 fours are
8.
8.
451.
1 fours are
4.
4.
44. 41.
1 fours are 4.
4. Yes, sir.
So what is the quotient?
011241.
You check whether this into 41 will give this number.
Yes, sir.
So how it is? How is this method?
Good. Very good.
Very nice, sir.
Now we'll
Very
take one
nice.
more. So how much big number? How much big
Sir,
number?
waiting. Sir, waiting for remainder part, sir.
Huh?
So waiting for that remainder part. You said in negative oscillator,
Now
we can
that
get
that
to
is
know.
that is somewhat different process. Later on, first
Oh,
you be perfect with this.
Okay,
example.
sir. Okay, sir. Yes, sir.
First only number ending with 1, 3, 4, 9, and this. Here are also there are 2 methods are there. But
Yes,
at least one you be perfect. Later on we can go for second method. That is no problem. Then we
Yes.
have to go for reverse osculation to see if quotient and remainder of both we can get it simultaneously in a single line. That too.
Yes.
Okay. So you take 1637151. How much big number is just you can see 1637 151 by 51. So whether this number is divisible by 51. So Q is equal to how much?
5.
5. So 5 ones are 5,
Five.
minus 5 gives 0. The rest
163710.
remains same. Then 0 means 1, 6, 3, 7, 1 into 5 means again 5 is 32.
1632.
2 5s are 10.
153.
3 5s are 15.
15. 0.
So what is the quotient?
32101.
Check 32101 into 51 gives this number.
Yes, sir. It's the same.
So any problem here?
No, sir.
So now we will be learning with ending with 3 and ending with 7. But the problem here is you may not get ending with 9 or ending with 0. Some other number we will get. Still it is divisible. So in that case, if we are finding out quotient, you have to learn much more. So now here onwards, we will see whether it is divisible or not. That's all at present. Later on, we can find it out. Okay. So now ending with 1 and ending with 9. Is there any difficulty?
No, sir.
So like this, you yourself can build up some examples, or in your calculator, you take one number ending with 9 or ending with 1 into some 4, 5 digit or 6, 7 digit. If you want to carry out bigger one like this, you can do and carry on. No problem. Now just I will take this example. I will tell only one example. Just I will tell you how it is carried out in a single line. It's another method I will tell you only for 9. Later on I will go for 3 and 7. Okay, I will take the same example 2 0 9 4 5 6. So you write it like this, keeping some gap 2 0 9 4 5 6. Here what you were doing, you were adding this product to the whole number, correct? To the whole number you were adding it. Yes?
Yes.
Yes, sir.
Now you have to add only to this number, on the next number.
Last.
Last, whatever you mean. Now it is P is equal to
12.
2. 19 means 2. I will write divided by 19. So P is equal to
2.
So 6 to the 12
12.
plus 5.
17.
You write on 17 here, that's all. Okay. Now what is the unit place? Osculate 17 means
7.
what? 7 to the
7. 14.
14 plus 1.
15.
15. Add this 15 here. 15 plus 4.
1. 19.
19. You write 19. Now osculate 9. 9 to the 18.
18.
18 plus
18 plus
1.
1.
19.
19.
19 plus
18
this
plus
9.
29.
28.
You write
28.
20. Now osculate 8. 8 to the
16.
16 plus
16
2
plus 2, 18. 18 plus 0,
plus
18.
0, 18. Now 8 to
8
the
plus
16,
16
17.
plus 7, 17 plus 2, 19.
So if you get 19 at the end, it is divisible. That's all. Only in one line you go.
This is more easy.
Super, sir.
Now, but for a negative oscillator, you have to learn something. That's why I didn't teach you.
Yes, sir.
Positive, you can start with this. No problem.
Okay.
Negative, next time we'll take after completion of 3 and 7. Huh? So now what is left here? What you have oscillated? 6, 7, 9, 8, 8, 9. Give the value last from 10, others from 9. 9, 0,
0,
1,
1,
8, 1,
1,
0,
0, 2, 4.
last from 10. 1, 1, 0, 2, 1, 1, 0, 2. So add the end. If you don't get 19, that means it is not. So like this, you can follow this. Okay.
Sir, for negative also we can do in this way.
Negative in this way, there's some changes there.
Okay.
Because, okay, actually for, yes. Earlier I have taken example for 11, correct? One example I
Ending.
2, 3, 4, 4, 3, 2. This example I had taken, no? So actually what we do, I will tell you now. 2, 3, 4, 2, 3, 4 by 11. Okay. So here
Q is
4, 3, 2, sir.
Q is equal to 1.
1.
Okay. Now normally what you were doing, you were doing this plus this plus this and this plus this plus this, both were same, 9 and 9 cancels. That's what you were doing, correct? Conventional. But now Q is equal to how much? 1.
One.
So here you are subtracting this 9 from this 9. That means one was positive, another was negative. And that is what is done in case when ends with 1. Here unit is positive. You have to consider, you know Wien-Coulomb number. You have learned something about Wien-Coulomb number.
Yes, sir.
So the same thing. This is positive, this is negative. Just you give negative mark, that's all. Positive, negative, positive, negative. Adds everything. Means what? Plus 4 minus 4 cancel. Plus 3 minus 3 cancel. Plus 2 minus 2 cancel. 0. That's why it is divisible. But by this method, you can just see 4 ones are 4. Correct? What you have to do again, the same thing. For 19, what you have done? Here, 3819. What you have done? Divided by 19. What you have done? P is equal to 2.
2.
9 to the 18, add 1 here. 9 to the 18 and 1, 19. Then you osculated this 9 to the 18 and 1, 19 and 8, 27.
27.
7 to the 14, 15, 16 and 3, 19. Like this you have done, correct?
Yes.
The same way you have to do, but now you have to consider this as negative.
Negative.
The rest is same. And here also you may get negative. Okay, now here just I will tell you this method. Later on we'll see. Now here it is Q is equal to how much? 1.
1.
So 4 ones are 4, minus 3 is how much?
1.
1.
You write it here like this. Here you are adding it and writing. Here you are subtracting it and writing. So 1 ones are 2. So 1 ones are 1
One's a 1.
plus 2. Here it is, this is plus.
3.
3 ones are 3 minus 4.
1.
3 ones are
Minus
3 minus 4.
Minus
Minus
1.
1.
So bar 1.
Minus.
Clear?
Yes.
Now bar 1 into 1.
Minus
is bar-
1.
minus
Bar
1
1.
plus 3.
2.
Now 2 ones are 2 and minus 2.
0.
So it is divisible. Now what you have osculated, you directly write whatever answer is there. Okay. So it is 2, here it is bar 1, here it is 3, here it is 1,
1. 4.
4. Okay. But what you have done here, alternate positive, negative.
Mm.
Here also you have to do the same thing. This is plus, this becomes minus. So just I will write it separately. So this 4 I will write. If it is plus, you write minus. If it is minus, write plus. Only for second, 4th, 6th, and so on. So first is as it is. This plus 1 becomes minus 1. 3 as it is. Minus 1 becomes plus 1.
Plus.
Because it is minus, reverse. Plus becomes minus, so minus becomes plus. Is 2. Now here, what is 3 bar 1? How much?
29.
And this 4 and 2 1. This is the question. So this little confusion might be there. That's why I did. So just you can see 21294 into 11 gives 2342. Is it clear?
Yes, sir.
So alternately, you have to change the sign of 2nd, 4th, 6th, 7th as it is, 8th as it is, 10th. Sign change means plus becomes minus, minus becomes plus. That's and that you will get if you get Wien-Coulomb number normalized. These are the 2 points. That's why I didn't teach that method. You will continuously subtract. Now when it ends So for ending with 1, what you do? Subtract 1 to get 0 at the end. X and 0. I will take a write 31. I will write it as 30 and cancel. If it ending with 9, so 29, here we add 1 to get 30 and cancel. So this gives P, this gives
Q.
Q. Now when it ends with 7, what is to be done? Or 17, what is to be done? You see, by a small number you multiply so that you get either 1 or 9, which is easier, you can take. 17 into 3 is how much?
21. 20, 51.
So here it is Q.
Ending 1,
Q is equal to
5, 6, 5.
51 minus
5.
1. Now if I multiply by 7, how much it is?
What?
So I
9.
should get either 1 or 9.
12. P.
So here P is equal to how much?
12. 12.
So whether this is easier to operate or this is easier to operate. P is easier to operate or Q is easier to operate. You will get in both you will get the same number, same style. So we'll use earlier methods. Okay. Now we are not worrying about quotient part, only whether the number is divisible or not. I will take one example, 17 small example, 3689 divided by 70. So P is equal to, I will first P is equal to 12. I will solve this also, okay? 3, 6, 8, 9. Now P is equal to how much?
12.
12. 12 9s are 108, 116. Now unit place,
6.
72, 83,
72.
89.
89.
Now
81.
108 plus 8, 116, 119. So we are getting 119. Again, you have to see what is the, so 17 sevens are 119, or what is you are getting 119. So it is divisible. It is now we are getting 0, 9 means 0, 6 means 3, 9 means 1. 31 is the quotient, but for it is 119, not for 70. Is it clear? Because we are multiplying and taking a number ending with 9. That's why you have to multiply by 7, because you have multiplied by 7 to get 9. 7 1s are 7, 7 3s are 20. So this is the quotient for 119, whereas this is the quotient for 17. So you can check whether 217 into 3689 is equal 17 divided by is equal to 36. 217 into 17, whether it gives 3689. So that's why at present you worry only whether it is divisible or not. That's okay. So if it is 117, 118, whatever other than 119 or multiple, it is not divisible. The second example is 368 by 17. Now Q is equal to how much?
5.
5. So when Q is there means first
35.
positive, second, first positive, second negative, third positive.
Negative.
That is important. Most important is what? Q. For Q, most important is second, fourth, sixth negative. That you have to remember. Now you carry out 9 5 are 45. 45 minus
5 minus 8,
37.
36.
45 parts.
7.
45 and 8. What's a not? 45 minus 8. 45. This is bar 8 means minus 8. But again, here also second, fourth like this. This will be negative. You have to just give bar. That's all. That's why I did not teach this method. Now it is 7 5 are
35
35 minus 3.
plus 3, 32.
32
32 plus 6,
plus 6.
38.
Now 8 5 this
Plus
again
40.
minus.
Minus 40 minus 3.
40 minus 3 minus 3 means 40 minus 6.
40 minus 6. 32. For 34.
17 2 is 34.
Yes.
Yes, it is divisible. Clear?
Yes, sir.
Otherwise, you take this 3, 6, 8, 9. 9 5 is 45. Subtract 45. Earlier method. 3 5 is 15. Subtract 15. 17. You get this. So it is divisible. It is divisible. It is divisible. Now it is 3, 6, 8, 9 by 12. 108. You add 108 here. So 7 7 4. 12 6 are 72. Use 9 and 11. 190. Yes. Clear? All 4 methods.
Yes, sir.
So either of you, but it is very easy because when Q is smaller one, use this. When P is smaller, use that one. That's all. And here, one more thing. What is P is how much? For 17. For 17, P is equal to how much?
12.
12. Q is equal to how much? Q is equal to how much?
5.
5. What is P plus Q is how much?
17.
Which is divisor itself. Say each number will have positive and negative oscillator. If you know one, you can find other. That's all. So for 19, P is equal to how much? For 19, P is equal to 2. Therefore, Q is equal to how much? 19 minus 2.
17.
That's all. But which is easy to operate? Now 17 is easy to operate or 2?
2, sir.
That's why when number ends with 9, use P. When number ends with 1, use Q.
Yes, so
Now here it is, for 31 it is 3. So 31 minus 3 is how much? 28. 28 is P. So P is 28, Q is 3. So which is easier?
3.
Like this. And here Q is 3, P is 3, and Q will be 26. Here Q is 3, P is 20. So in this case, Q is better for ending with 1, P is better for ending with 9. And here also into 3, if you do, it will be easier. For 13, number ending with 3, again multiply by 3, that will be much easier. One more example I will take. Complete later on we'll say. Okay. 46023 divided by 23. So here it is not ending with 1 also, not ending with 9 also. So you can have
multiply by 3.
Multiply by 3 to get 69.
29.
Therefore, P is equal to
6.
7.
7.
69 plus 1.
Yes.
So P is equal to 7. Carry on. If P is equal to 7, Q will be how much? 23 minus 7.
160.
You do it here. 23 into 7 you do, how much it is? 7 3s are 21, carry over
160.
to 161. So 161 minus 1 is 160. So 16 is Q. So instead of doing, if you know P, you can find Q, subtract 23 minus 7. If you know Q, subtract 23 minus 16, you will get 7. So which is easier? 7 is easier or 6? 7. So
7.
carry on with 7. So always ending with 3, multiply by 3. Ending with 7, multiply by 3. Both cases multiply by 3, so that you will always get smaller P or Q. Okay. Now you carry on with 7. Just 7 3
21.
21 plus 2.
23. 23 plus 20.
21. 7 3 are 21. 61 62 72 82 83. We are adding now because
21.
3 7 are 21. 21 means 69. 69 means 9. 23 3 are 69. Yes, it is the last two. And one more fact is, when it is divisible, you will get the same number repeated. Now you osculate again. 9 7 are 63 plus 6, 69. Again you are getting 9 69. That means it is divisible by 23, divisible by 6. If you want, you can give one example ending with 3. Any 33, 43, 43 into something you give. Last example we'll take. Yes.
Yes, sir. Any example we can give.
Any
Whether it is okay. 4 5 6
Ah.
7 6 7
Ah.
2 3.
2 times 6 7.
No, 2 3. After this, after 7 2
Ah.
3.
3.
4 5 6 7 2 3. Whether this is divisible by
43.
43. 43 into 3 is how much? 3 3 is a 9. 4 3 is a 12. Means P is equal to 129 plus 1, 130, cancel 0, 13. So 13 3 is a 39.
39.
We can use now other method. It is just sometimes you do this method, sometimes you do this method, so that all methods you will practice. Now you add only to this. 39 plus 2, 41. 1 into 13, 13 plus 4, 17 plus 7.
24.
29. 4.
No, 4 into 13, 52
plus 2.
plus 2,
56.
54 and 6, 60.
62.
60.
60. Yes.
13 4 the 52,
Yeah.
54 and 6, 60.
60.
0 into 13, 0. So 6 plus 5,
11.
11.
13 1 the 13,
13 plus 1
14,
14.
and
14
4.
plus 4 18.
Whether this is divisible,
No.
No,
so the whole number is not divisible.
not divisible.
Yes. Is it clear?
Yes, sir.
Like this you practice. So next time, whenever I get next week, any one day, we can continue with this. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
So did you like this method?
Yes, sir.
So you practice like this only. Okay.
Okay, sir. Thank you so much.
Okay. Bye.
Thank
Bye.
you, sir.
Thank you for your valuable time, sir. Thank you.
Thank you.